Good morning, everyone. Welcome to the new topic for today. So, today's lesson we are going to learn about Chapter 5, Congruency and Similarity. Okay, so for your textbook is in page 120 onwards. Okay, this is quite a big topic here. Page 120 from your textbook is about congruency and similarity. Right, so today we're going to learn new topics. Okay, so I will start off from congruency. I'll explain to you what is congruency, and as for similarity, we will learn after we learn this congruency. Okay, so this is my notes here. Okay, I would like you to copy everything. Okay, you can write it in your own way, colorful, or you can doodle your notebook and anything. I don't mind. Okay, it's all up to you as long as you feel comfortable on your own handwriting and your own notes, right? Okay, so I start out with congruence. Okay, so the definition for the congruence. Okay, so let's say we have congruent triangles. Okay, we can say that the triangles are congruent if the triangles have exact same shape and size. Okay, both of the triangles, let's say we are comparing two triangles, we can say that two congruent triangles are on the same shape and also same size, then we can say that they are congruent. Okay, so both of the triangles, for example, if we have two congruent triangles here, let's say you look at here ABC and XYZ. Okay, these two triangles, we can say that they are congruent if they have same shape and same size, exactly the same. So we can say that they are exact duplicates of each other. Okay, exact duplicates of each other. Okay, so we can also say that it's equal corresponding sides and equal corresponding angles. Okay, corresponding as in both of the triangles have both equal same sides. Yeah, equal sides and both equal angles. Okay, I will explain to you in detailed way later. Okay, but in fact, if we say that they are congruent, we could pick up, for example, this triangle ABC. We can pick up this triangle ABC and fit exactly over the triangle of XYZ. Okay, it's like we can pick ABC and put it on the XYZ. Okay, it's like you're putting A on the X. Okay, you're putting the A on the X, and this B on the Y, and this C on the Z, and it's exactly the same. Okay, and it's matched. It is matched to each other. Okay, then we can say that they are congruent. Right? So ABC triangle, XYZ triangle, we can say that they are congruent. Okay, to show that they are really congruent. Okay, we must say that they have the same sides. Okay, so corresponding sides are equal. Okay, corresponding sides are equal. So if we have AB and this XY here, okay, if both of these sides are the same, okay, that's why we call it corresponding sides. Corresponding sides as in AB compare with XY. Okay, if they are the same, so AB equals to XY, they have the same side. Okay, one of them are the same. Okay, we cannot say that they are congruent yet. Okay, and if we have the second length, this AC corresponding with the XZ sides, if they are the same, we can write that AC is equals to XZ. Okay, or if we have ABC and XYZ here, I mean BC and YZ, the length of BC and YZ, if they are the same, BC equals to YZ. Okay, we can say that their corresponding sides are equal. Okay, not only the sides are the same, but the angles must be the same too. Okay, so corresponding angles must be the same, must be equal. Okay, so corresponding sides, corresponding angles, exactly the same, so they are called congruent. Okay, corresponding angles as in, okay, we have angle here. This angle BAC, we call this as angle BAC. So we write in this way, angle BAC. Okay. And the corresponding angle is equals to, the corresponding angle is over here, which is angle YXZ. Okay, we call it angle YXZ. Okay, so angle BAC, corresponding angle YXZ. Okay, both equal, right? So if we have angle ABC corresponding with the angle XYZ, okay, we write in this way, angle ABC equals to angle of XYZ. Okay, and this angle over here and this angle over here corresponding to each other, so angle of, we call it angle of ACB equals to angle of XZY. Okay, so we can call these two triangles congruent when we have all the sides are equal and all the angles are equal, as in corresponding sides are equal and corresponding angles are equal. Okay, so we must show every sides, every angles. If they are the same, then we can conclude that they are congruent. Okay, so we know what is congruent now. Alright, so we write congruent triangle as this way. Okay, hence is these three dots, and triangle of ABC. Okay, and then we have three bars. It represents is congruent to. Okay, triangle ABC is congruent to triangle XYZ. Okay, we must follow the order, as in ABC is congruent to XYZ. Okay, so there are a few things I want you to note down. First is the order is important. Okay, the order is important. So because when we name the triangles, the sides, the angles must follow the order. Okay, what I mean by follow the order is, okay, for example, your ABC triangle is congruent to triangle XYZ, right? But we cannot write in this way, triangle of ABC is congruent with triangle ZYX. Okay, because the angle of this A, I mean the point on this A with the point on this Z is different. Okay, A and Z here is different. Okay, so if we say ABC, okay, ABC in this way, and triangle of ZYX like this is different. Okay, it's different because the point A and the point Z, when we start off point A and point Z, they are different. Okay, so the order is very important. Okay, so when we write down, we cannot write in this way because they are different, so we have to make it in the same order, which is triangle ABC. Okay, the first one ABC is same with the triangle of triangle XYZ, like that. Okay, but we can also write in this way. So if triangle of, let's say you start from BAC, so triangle of BAC is congruent with triangle of, okay, so if we start off from B, okay, we start off from, if let's say we are starting off from B, so the triangle on your right side here, if we start from B, we must start off from Y as well. So the triangle of BAC will be same as triangle, is congruent to triangle YXZ. Okay, the order is very important here. So if we start off from B, then we start off from Y. Okay. This one okay, this one okay. Or we can also write a triangle of, if we want to start off from C, let's say, triangle of C, let's say AB is congruent with triangle of, okay, now your turn. Try to figure out. If triangle of CAB, then it is congruent to triangle of what? Okay, so if we CAB, we start from C and then A and then B, so therefore it will be ZXY. Right? So it's triangle ZXY. This one also can. Okay? Any of these three also okay. You write only one time. Okay? To show that they are congruent. Okay, when we show that they are congruent, when triangle, we can choose either one of these to write it down. Okay? For the triangle, as long as the order is important, it's the same order. Okay, so if A, B, C, this is X, Y, Z. So if BAC, we start off with B first, right? So BAC, so therefore this one is YXZ. The order is the same. Can you see that? Okay, so in my notes here, I will just write down only one. Okay, you can write down the rest also. Okay, I don't mind, but let's not make the notes more complicated, so I write in one time only. Okay, but the sides must be all the same, corresponding sides and corresponding angles. Okay, so the first one, order is important especially when we name the triangles, the sides and the angles. Okay, and just now we name the triangles. How about the sides? The sides, when we name it, if we name AB equals to XY, we cannot name AB equals to YX. It's different, because when we start off with A, then we start off with X as well. Okay, so this one, the order is not in the same order, so we cannot write it that way. Okay, it's considered wrong. Alright. Okay, so second one, the orientation does not affect congruency. Okay, the orientation as in if it rotates, if you rotate the triangle, it does not affect the congruency. Okay, so the orientation does not affect congruency. So I give you an example. Okay, this one you don't need to copy. So these two triangles are congruent. Okay, let's say they're congruent, and if they rotate, it will still congruent. Okay, it is still a congruent triangles because they have the same shape, same size, they have the same corresponding sides, they have the same corresponding angles. Okay, so rotation, if you rotate the triangle, they are still congruent. Okay, if we reflect the triangles, we flip it, these two triangles, they will still be congruent. Okay, if we translate, we move the triangle to any way, the triangle, as long as they are they suit on, they have the same corresponding angles and side, they have the same shapes and same size, they will still be congruent. Okay, so no matter how you rotate them, you reflect, translate, they will still congruent. Okay, unless if the two triangles are not the same shape or not the same size, then they are not called congruent. Okay, so orientation does not affect congruency. So what kind of orientation? Rotation, reflection, translation. Okay, all these. Okay, so the third one that I want you to note down is, okay, look at this 3 bar. Look at this 3 bar here. Okay, it means is congruent to, okay, or is identical to. That is why when I write down just now, the 3 bars over here represent triangle ABC is congruent to triangle XYZ. Okay, so if we were to write down in words, it means triangle ABC is congruent to triangle XYZ. Y, Z. Okay, this 3 bar means is congruent to. Okay, so there are books or there are some writers, they write, instead of 3 bars, they write in this sign, this symbol, okay, with a curve and double bar. Okay, this one also means is congruent to. Okay, it depends on some writers, they write it in this way, is congruent to, and some write in 3 bars here. So we just follow the textbook. The textbook is written in this way, 3 bars here, the 3 bars which represent as is congruent to. Okay, so the fourth thing, the last thing that I want you to know is we actually don't need to know all corresponding angles and all sides are equal in order to confirm the 2 triangles are equal. Okay, just like what I mentioned here, you see I have 3 corresponding sides equal, 3 corresponding angles are equal. We don't need to actually point out every single side and every single angles to conclude that and or to confirm that they are congruent. Okay, we don't need to show all the sides, all the angles exactly the same, all the 6 items here. Okay, the 3 sides and the 3 angles, everything to show out exactly same sides, same angles to show that they are congruent. Okay, so how do we make sure that the triangles are congruent without listing all these 6 down? Okay, we don't need to list out all these 6 items here to show that they are congruent. Okay, so we have tests for the congruence. Okay, there are certain conditions that we have to meet up. Okay, we have to write it down in order to show that they are congruent. Okay, we don't need to list all 6, but there are certain angles, certain sides that we have to mention in order to show that, to prove that they are congruent. Okay, so I will write down one by one. I will show you one by one here. Okay, one of the tests of the congruency, or one of the condition to prove that they are congruent triangles is, okay, I'll write here. Okay, the triangle of ABC, XYZ here. Okay, if we have nothing here, we are not given anything, we cannot show that they are congruent. Okay, it's just 2 triangles drawing out. It seems like it's congruent. Okay, it seems like the shape are the same, the sides are the same, it seems like they are the same, but we cannot prove that they are actually congruent. Okay, we cannot prove that they are actually congruent. Why? Okay, so ABC can be maybe slightly smaller than the XYZ. We don't know, right? We don't know because they didn't show what size, they didn't show what angle, they didn't show the side, anything, so we cannot prove that they are congruent. Okay, we can only prove that they are congruent if we have SSS. Okay, this SSS stand for sides, sides, or just SID, okay? Side. Okay, this 3S represents side. It means that, okay, if we are not given any angles, but if we are given the side AB same with the side of XY, and AC, side of AC same with the side of XZ, and side of BC same with side of YZ, if we are given these 3 sides without given any angles, we can conclude that they are, both of these triangles are congruent. Okay, so again, we don't need to list everything down. We don't need to list all the 6. We don't need to have all the 6 items like I mentioned just now. 3 sides and 3 angles, both corresponding sides and corresponding angles, all these 6 items. Okay, we have 6 items, 1, 2, 3, 4, 5, 6. We don't need to mention all these 6 in order to prove that they are congruent. Okay, we only need the first condition, the first test, which is SSS. Okay, we are not given any angles, but we are given side. Okay, 3 of the sides. If we are given 3 sides are the same, we can conclude that they are congruent. Okay, so question they will ask you to state the reason. Okay, the reason when we write it down is in this way. Okay, the first one is when AB is equals to XY. Okay, the order is important, remember. So when we write AB, we must write XY. We cannot write YX. Okay, the first side is given. The second side, the corresponding sides, which is AC and XZ, the corresponding sides are the same. The third one, BC equals to YZ. Okay, so if we are given all these sides, the first sides, the second sides, and the third sides, okay, we are given these 3 corresponding sides are the same. Therefore, okay, with 3 dot means hence, or therefore, we can conclude that the triangle of ABC is congruent to triangle XYZ. Okay, see, we are not listing all the 6 items down. We only have these 3. Side, side, side. Okay, these 3 side. Okay, these 3 side represent first side, second side, and 3 sides, corresponding sides here. They are the same, so we can prove that these 2 triangles are congruent. Okay. Okay, so this is the first proof that they are congruent. The second one, SAS. What does it mean by SAS? SAS is the initial for side, angle, side. Okay, side, angle, side. Okay, so it means that if we are given corresponding side, corresponding angle, and another corresponding side, we are given all these 3, we can conclude that they are congruent. Okay, so let's say we are given the first side, okay, and then we are given the corresponding angle, and we are given the second side here. Okay, we can conclude that these 2 triangles are congruent. Okay, to state that down, the reasoning, when we write down, we must write in this way. The side of AB is equals to the side of XY. Okay, this is under side, same corresponding side, which I write down as S. Okay, and the second one, the angle of ABC, the green one, yeah, is equals to the angle of XYZ. Okay, they have the same corresponding angle. And if we are given BC length equals to the length of YZ, which we have a corresponding another corresponding side. If we are given these 3, without given the other side, without given the other 2 angles, we are only given these 3 items, we can say that therefore we can say that triangle ABC is congruent to triangle XYZ. Okay, and I want you to note down here, okay, the angle here must be included between 2 sides. Okay, so please note this, the angles in SAS, okay, the angle in SAS must be included between 2 sides. Okay, must be included. It means that this angle, this side here and this side this angle must be in between these 2 sides. Okay, if we have 2 triangles, let's say 2 triangles like this, if we are given side here same and the other side here same, but the angles is here, these 2 corresponding angles, these 2 sides, even though this side and this side is the same as, this side and this side is the same as, this angle and this angle is A, we cannot say that this is SAS, cannot, because the angle here is not included between two sides. It means that it's not in between, unless if the angle given is here. So the angle is included between two sides here, so we can say that this is SAS. Okay. Okay, I show you from the textbook here. Okay, congruent figure. Okay, this is side congruence test. Okay, so the side same with this side, this same with this, and this same with this. So this is SSS. Okay, SSS. And then if we have side angle side, okay, side angle side, the angle must be included between two sides. Okay, you see this side here, and this side, and this angle is in between these two sides. Okay. Okay, how about this? Look at this. This is also side, and this is also side, and angle, this is also side. But we cannot say that this is angle, side angle, because the angle here is not included between two sides. Okay, this angle is opposite the side here. Okay, and you can see that these two triangle is obviously not congruent. You see this and this. The size not the same, the shape is not even the same. So that is why side angle side cannot be proven in this way. Okay, it only can be proven if we have included angles and two corresponding sides. Okay, so we have two of these tests, congruency test, SSS, SAS. Okay, and we have another two more. Okay, the third one we call it as ASA or AAS. Okay, both of these is the same. Okay, angle side angle. Okay, how is it angle side angle? If we are given the first angle here and this angle here, if we are given these two angles, which is corresponding angles, the same, and if we are given this side and this side same, and the other angle here same with this angle here, okay, so we call it angle side angle. Okay, and the side is actually included between these two angles, isn't it? Okay, or we can have, okay, these two triangle, angle here same with this angle, okay, and the side BC and this YZ side same, and the third one, angle here same with this angle here. Okay, even though it's not, the side is not included between these two angles, we can also prove that they are congruent. Okay, right. So again, for the angle side angle, okay, I mentioned this one before. I mentioned the other one. These two angles, if these two corresponding angles are the same, and the corresponding side, one of the side here is the same, we can conclude that they are congruent. Okay, to write the reason down, to write it down in a way that they are congruent, we write like this: angle of ABC, if it's equals to the angle of X, Y, Z, and the side of BC is equals to the side of YZ, and the angle of ACB is equal to the angle of XZY, which we can say that this angle, this corresponding side, and this corresponding angle, okay, is represented in this way, angle side angle. So we can conclude that angle ABC is congruent to triangle XYZ. Okay? Okay. So the side here is included between two angles. But what if it's not included like this triangle? Okay, what if this side is not in between the two angles? We can also say that they are congruent. Okay, except for this SAS, it must be included. Okay, this is a must be included between two sides. Okay, must be included as in it must be in between these two sides lah, right? Okay, but for AAS, two angles and one side, okay, it's not necessary to be included. It's not necessary to be in between. Alright? Okay, so here we can write like this: the angle of ABC equals to angle of XYZ. Okay, and the side here, okay, if we write the side also can, we write the angle here also can. Any of these first is not necessary in order. Okay, A, B, C, X, Y, Z. When we name the triangles, it must be in order. But when we mention the angle and the side and the angle, it doesn't really have to be in order. Okay, I will explain that later. Okay, ABC angle equals to angle of XYZ. BC length is equals to length of YZ, and angle BAC equals to angle YXZ. Okay, so when we write this actually is still ASA. So if we write this one first, and then we write down this one second, and we write down this one last one, okay, it's the same, it's okay, right? Or if you wish to write down side first, the first one, if the first one you write down this first, and then second one you write this, the third one you write this, also can. Okay, as long as you show that, you prove that these two triangles and one of these side, okay, they are the same, then therefore we can conclude that this triangle of ABC is congruent to triangle of XYZ. Okay. Okay, you want to write down angle, side first also can, it's the same. Okay, so AAS here, it means that your angle side, it doesn't need to be included, it doesn't need to be between the two angles. Okay, this angle, side angle, which means the side is included between angles, is also called congruent. Okay, the angle side, which the side is not between the two angles, we can say that they are congruent too. Okay, they are also called congruent. Okay, except for SAS, it's a must. Okay, it's a must. Okay, so we have tests for congruence here. We have 3 to prove that they are congruent triangles, and we have the last one, which we call RHS. Okay, RHS stands for right angle. Okay, the right angle, 90 degree, and H here represented as hypotenuse, and this S here represents side. Right angle, hypotenuse, and side. So when we have both of the triangles with right angle, okay, if both are also right angle, and if we have the hypotenuse is the length opposite the 90 degree, the hypotenuse both are the same, and if we are given one of the side, okay, either one of the side AB or BC also can. Okay, BC, let's say this BC here, same with the side YZ, we can say that these two triangles are congruent. Okay, so when we write this down, okay, the right angle first, the angle of ABC is equal to the angle of x, y, z. Okay, it's given 90 degree. And if we are given the hypotenuse AC, which is equals to xz, corresponding hypotenuse, and if we are given the other side, BC equals to YZ, okay, so we can say that this is RHS. Okay, therefore this triangle of ABC is congruent to triangle of XYZ. Okay, so you write all this down in your own way. I mean, as in the triangles, you draw it in your own way. You write it all these side angle, and RHS in a colorful way, or any doodle form. It's all up to you. Okay, so as long as all this I want to see in your notebook. Okay, so again, to show the congruence of the triangles, okay, I conclude this, okay, before I end my lesson today. So this congruency, the congruence triangles must have exact same shape and size, and they must have equal corresponding sides and corresponding angles. Okay, we can see that there are 3 pairs of sides and 3 pairs of angles that must be equal in order to show that they are congruent. Okay, but we don't need to list down, okay, to prove the triangles are congruent, we don't need to list down all the 6 items here to show that they are congruent. Okay, as long as they are given SSS or SAS or angle side angle, okay, 2 angle and 1 side, or one right angle, 1 hypotenuse, I mean corresponding, yeah, and another side. Okay, if they are given in this way, we can conclude that they are congruent. Okay, 3 items instead of 6 items. You get what I mean? Okay, 3 items instead of all the 6 items here that I list down just now. Okay, you see three sides, 3 angles to prove that they are congruent. No need all of them. Okay, we only need 3 items to prove that and to test that they are congruent. Okay, so the notes you list down. Okay, and then this page, I want to go through with you first. Okay, on this try it 1. Okay, try it 1. You don't need to copy this into your notebook. You don't need to do this. You just need to listen here. Okay, so determine whether each of the following pairs of figures are congruent. Okay, we can see that this one, okay, we don't need to prove, we just look at it. Do you think it's congruent? Okay, yes, it seems like congruent. We just write yes, but to prove that they're congruent, it's not just as easy as writing down yes. Okay, I will discuss with you on the next lesson, but this one just to see whether with your naked eyes, look at it, it seems like a congruent, right? Okay, so just write yes. Okay, how about B? Does it look like a congruent triangle to you for both? I mean, not triangle, quadrilateral here. It's no. Okay, this is definitely not congruent. It's not the same shape at all. Part C is no, it's not congruent at all. And part D, okay, is yes. Okay, it seems like this pentagon here can be picked up and put onto this pentagon over here, right? Okay, so we can say that they are congruent. But to prove, as I said just now, to prove that they're congruent, we must undergo this test. It must be shown in your diagram, either side or side angle or angle side angle or right angle hypotenuse side, in order to prove that they are congruent. Okay, so that's all from me today. Okay, next lesson we will go through questions for you to understand more about congruent triangles. Okay, that's all for me. Thank you. Bye.